Alright, so this video is going to be a little bit of an experiment. I tried going through with a little bit of a script I made in my head as I tried to record each part, but I figured that I ought to just kind of wing this. Anyway, we're still going to answer the problem of the video title. However, I'm not going to make cuts for if I cough or if I forget what the next topic is. I'm just going to continue on without any, stupid cuts or anything, unless, something really external is going on and I have to get up for a moment. Anyway, so let's answer the question. Some eventually, if you were like most people, that you were in some kind of high school class and your teacher approached you and gave you a simple question like this, and you thought, hey, well, hey, I can do this. X is equal to 1. But your teacher said, I want justification. And you say, well, simple. I can put 1 here and I get 1 plus 1 is equal to 2. But what you quickly found out was that that's not what your teacher meant. In fact, your teacher wanted a list of steps supported by actual mathematical rules you can follow to actually get to showing somebody that x has to be equal to 1. So what are those rules? The first one that you know of is to subtract 1 from both sides, but we also have to supply our reasoning. So there is no reasoning for this one, it's just a given. This is the thing we assume to be true. Our goal is to show that x is equal to 1. So this is what we're given. The first the first step is to subtract 1 from both sides. So x plus 1, we have to put these in parentheses because this was already here. We were adding stuff to it, so it's got to go in parentheses. This is just good practice. And then so we just subtract both sides by 1, and the rule is that we're subtracting 1 on both sides. And the justification here is the both sides thing, because the first rule that they hammered into your head was that this is algebra. If you have an equation and you do something algebraic to one side, do it to the other side too, and the algebraic in the equation itself will, it'll still hold. It'll still be fine. So what is the next rule? Well, you want to eventually get to x is equal to 1 or x plus 0 is equal to 1. So how do you do that? Well, now you have to get rid of this 1 and this negative 1. And you already know that they go to 0, but there's an actual mathematical rule that's going on here. And that rule is pretty simple. It is the associative law. And I'm just going to call this A when I'm justifying stuff. And this is that x plus y plus z is the same thing as x plus y plus z if I switch the parentheses around. So basically, I can move these parentheses to be around this 1 and this negative 1 to get x plus 1 minus 1 is equal to 1. This is the associative law. And now I have x plus 0 is equal to 1, which is the 1 minus 1 is equal to 0. Specifically, they're inverses, they're opposites. They undo each other, they go to 0. And then finally, this one here, which is justified by x plus 0, and more clearly, y plus 0 is equal to 0 for any y. That is just a rule, and we're using it to simplify this left-hand side. So this is the chain of rules that your teacher was wanting you to get to. And the question here is, why should I be able to do this? Why should I spend all this time justifying my steps when I just know my way through the problem? Especially when the problem is this easy. And it turns out that there are a lot of easy things that you can talk about without really being able to provide good justification if you don't have any good practice. So here's an example. Here is the very simple equation, 0x is equal to 0. And my question to you is, why is this true? And most people who haven't seen like the last minute or two of this video will go, what do you mean justification? 0 times anything is 0. And that is not an answer. That is not a justification. So here is a mathematical justification. First of all, you know that y minus y is equal to 0. So instead of writing 0 here, I can just write y minus y inside of parentheses. So that's what I'm going to do. I'm going to write 0x is equal to y minus y in parentheses, and then times x on the right-hand side. So what do I do with this now? Well, we have the distributive property, which basically says that I'll use different letters here. A times B plus C is the same thing as AB plus AC. And so this means that I can just pull this, it's actually on the other side here, but I can just pull this x right next to these guys, right on the right here. And so that'll be equal to yx minus yx. There's actually a little bit less efficient of a way to do this that really gets your practice in. But anyway, this is still correct. This is still fine. This is just a more efficient proof that hopefully doesn't bore you to death. And now you see that this is just something minus itself, so this must be equal to 0. So what we started with was 0x. We just rewrote it. Then we rewrote that, and then we saw that what we rewrote was just 0. So just put the ends of the equation together. 0x must be equal to 0. And what we did was we used the substitution. 0 is just something minus itself. Put that in parentheses because you're chucking that into the equation. Then you have x on the outside on the right, so you just use the distributive property, and then you see that the result is nothing more than 0. So therefore, the thing we started with, which is this thing here, must also be 0. This thing is 0. Now here's the less efficient way, which is 0x equals 0 plus 0. Really nothing different from the first one, but instead of using something minus itself, we're just using the fact that 0 is just itself plus itself, right? 0 plus 0 is just simply 0. Now we use a distributive property again. I don't know why I wrote an x here. This is 0x plus 0x. Now we can put the ends of the equation together. 0x equals 0x plus 0x. And so far, all we've done is use the substitution to chuck this stuff right here. And then we use the distributive property to get that x out there to simplify this expression a little bit. And then what do we have here? Well, just to really make this simple, imagine that instead of 0x, we're writing a. That way we have a is equal to a plus a. So what do? Subtract both sides by a. Subtract both sides by a. These cancel. You get 0 equals a. We're going to do the same thing. We're going to subtract by 0x. So what do we get? 0x. And then we're going to do it on the right side as well. Minus 0x equals, and then since we're chucking it into the equation, we need to put this stuff in parentheses. 0x plus 0x minus 0x. The justification here is that we're doing it on both sides. Now, as you can see, this is just something minus itself. This is 0. And then on this side, we've got the associative property we can apply. So we'll get 0x plus parentheses 0x minus 0x. This is just something minus itself, so it goes to 0. 0 is equal to 0x plus 0. Anything plus 0 is just itself. 0 is equal to 0 plus x. So here are two proofs that 0 times anything is 0. So I can never find some special number y such that xy is like maybe equal to 1 or something. This is impossible. Sorry, I don't know what I was doing there. I can never find some special number y such that y0 is equal to 1, for example. This is impossible. This is impossible. It must be y0 is equal to 0. So now that we've seen some 0 stuff, let's look at a very related problem, which is division by 0. And in order to study division by 0, we need to think about what it even means to look at division. For example, division by 0 is basically a study of whether or not this makes sense for some number a. And before we even do that, let's consider division by other numbers. So example, 5 over 3. And the important thing here is not the 5, but it's the 3 on the bottom. Specifically, 5 over 3 is actually just 5 times 1 over 3. And this shouldn't be new to you if you're watching this channel. This should be pretty simple to you. And so what we actually care about here is this 1 over 3 piece here. And to show you what this means, I'll just give you some examples. 3 times 1 over 3 is equal to 1. 5 times 1 over 5 is 1. 1 times 1 over 1 is, this looks like a minus, but it's a multiplication sign. This is 1. And I don't know, let's go crazy here. Negative 100 times 1 over negative 100 is 1. So this symbol is actually just a fancy number that I don't want to write out. It's a decimal, of course, but it's just a fancy number such that if I take the bottom and I multiply them together, I get 1. So a over 0 is really just a way of writing a times 1 over 0. So what does it mean if you can divide by 0? Well, it means that this makes sense. This right here, all of this makes sense. But of course, as we saw, we don't care about this part. We care about what this means. This is a freaky special number. This is an ugly number I don't want to write, such that when I multiply by the denominator, I get 1. And if you don't remember why, well, a times 1 over a is defined to be a over a. And then you can just say that this is just equal to 1 times a over 1 times a. Just cancel the a's out, and you're left with 1 over 1. And if that's crazy for you, just think about what a over a is. This is a slices of a pizza cut into a slices. If you eat a slices of a pizza cut into a slices, you eat the entire pizza. You eat one pizza, right? So what does it mean if 1 over 0 makes sense? Well, just like these, what it means to make sense is that if I take the denominator and I multiply them together, I get 1. So if this makes sense, then I take the denominator out, and then I multiply by 1 over 0, and then I get, what do I get? In every case, I get 1. So if you want to say that division by 0 makes sense, then this is your claim. You're claiming that this equation is valid. However, I just gave you 2 proofs that say that 0 times 1 over 0 should be equal to 0. Now, of course, this is a bit of a shady equation because we're not even sure this thing exists, but just for the sake of it, assume that you trust me that anything times 0 is 0. So if you believe that you can divide by 0, then you also subscribe to this equation, because all this is the case of 0, and all of these equations over here, these examples, we just switch these numbers out with 0, which is the whole idea of division, right? So there is a number, a fancy number, such that when we multiply it by 0, we get 1. But we just saw earlier that when you multiply anything by 0, you get 0. So how can it be that 0 times something is 0, but in this case it's 1? I proved to you that it's always true. You always get 0. There's no exception. No matter what x is here, these factors cancel out. These things go to 0. They always reduce to nothing. So how could it be that I get a 1 here? And the answer is, you either choose this equation, and you choose my proofs to be correct too, which means that you subscribe to both of these equations, which means that 0 is equal to 1. Furthermore, this is algebra, so I can just multiply both sides by a number, and the equation will stay true, which means that 0 is equal to any number. So you're also saying that 0 is equal to everything. In particular, 0 is equal to 1. Or you can say that this is false and that this is true. And if you think that this is true, well, then you might as well just agree that this doesn't exist, because if it did exist, well, then this would have to exist. So really, both of these equations are bad, and the solution is to say that this thing just doesn't exist, and this equation in total is horrible. So in the simplest case, if you assume that you can divide by 0, you are setting up every single number to be equal to 0, which is a huge contradiction. You cannot just choose to avoid both. You can not choose to ignore both of these equations, because I've proven to you that the bottom one is true. Of course, if you replace this with something else that actually makes sense, the bottom one is true. But if you think that division makes sense, then you have to subscribe to what it even means to divide, which tells you that you get 1 out of this. But if you, but you see what I mean. There's a whole contradiction here, right? So you either have to point out to me where you don't like my proofs, or you really just don't get to say that this top equation is true. So here we've seen that it's not okay to um, divide by zero here. It just doesn't make sense. There are some mathematical places where you can divide by zero. For example, wheel theory, which no mathematician takes seriously, and also projective geometry, which isn't really division by zero, but it's close enough so you can actually get a taste of what it's like. I won't discuss it in this video just because it's beyond the scope of this lecture, and I also couldn't pull it out of my I couldn't pull it out of myself right now. It's just not ready. Anyway, that's that. So the original plan of this video was to also discuss things like zero divisors, which are some really weird things that pop up in different algebraic systems. However, I think that this video may have been a little bit dense for how quickly I was talking and going through the stuff. I think that instead of talking slowly, I'll recommend that you watch the video 2 or 3 times over just to get the ideas down if you don't really flush it all out the first time. You should hopefully understand and be able to recreate these proofs and demonstrations that I did in this video. Let's go back. For example, why 0 times anything is 0. You should be able to use your own knowledge to show that this is true, to recall what the associative property is, the distributive property. You should be able to make up your own examples, all that good stuff. And so I think in this video, I won't even bother going into the weird algebra stuff. I'll save it for the next video. However, I will just say that I've decided I'm not going to commit to series because every time I try to, I lose interest pretty quickly. So I'm just going to upload what I feel like. And for those of you who are new to my channel, I'm not actually a gaming YouTuber. I just kind of upload what I feel like, and what I was kind of not uploading for a while here. As you can see, it was a 7 month period. And just I had been hearing about a lot of hate for this gun in game, and so despite me missing half a mag on somebody, I just uploaded it, just because I wanted to. Point is, I'm not committing to any sort of schedule or series. I'll probably still upload these just when I feel like it instead of, every week or every 2 weeks or such. The more important thing to me is that you go down to this part of my channel and you tell me what you would like to see. I meant to put an others option here, but I didn't. So if you want to see something else, just comment down below what you want to see, and then also select something up here if it interests you. Select the most interesting thing because I'll probably do all of these, but I'll go off of what people want to see. Of course, I won't do like an upload schedule. I'll just upload when I feel like it. So yeah, thank you for watching this video. If you did, I hope you learned something. I would love to upload more math videos, especially those that don't really fit into the advanced math category, but still teach you a lot that you would like, hear about. Zero divisors are a very simple concept that anyone could understand, but you won't hear the word until you get into a math degree or maybe even a physics degree. I really don't know. Um, However, I would love to just make stuff that I feel like making. Let me know what you want to see. Watch the video a few times if it was a little bit too fast. And thank you for watching. I'm going to go now. If you're some kind of math whiz, if you're somebody who does math, feel free to let me know in the comments about whenever I make a mistake or say something stupid. Um, I'm always glad to learn from my mistakes. Anyway, peace.